Hi, my name is Brooke Bertrand, and I'm currently a junior at the University of Louisiana at Lafayette. I'm studying pre-pharmacy, and I aspire to one day get my PharmD degree and become a pharmacist. So what I'm going to talk about today has something to do with my major. So did you know that the pharmaceutical manufacturing processes of today are the same as they were in the 1950s? So my topic that I'm going to be talking about is continuous flow manufacturing and how it can alter the face of pharmaceutical production. So continuous flow manufacturing is a relatively new process in the pharmaceutical industry, and normally pharmaceuticals are produced by what's called batch manufacturing. And batch production, it just consists of making pharmaceuticals in batches according to a single manufacturing order, while continuous flow manufacturing can receive input and discharge your output simultaneously. So I have a picture here to help kind of explain this. So on the top picture is your batch production, and the bottom picture is your continuous flow production. So as the picture is saying, you have your active pharmaceutical ingredient, and once you get that, you have to transport it to somewhere else to get it to be put into a tablet form. So you're ultimately putting in batches according to the single manufacturing order, and it takes more time. So with your continuous flow manufacturing, you can receive your input and discharge your output simultaneously. So overall, you're putting in products in here, or you're putting in your raw materials in here, and then they're becoming active, and then you're getting your product, which is in the tablet form. So, and this is a simultaneous process. You can put in more while continuously making another drug, and it won't affect it. So, batch production's been used since before the 1950s. But continuous flow manufacturing is cleaner and more flexible and a more efficient way of manufacturing pharmaceuticals. So the goal is an ultimately balanced production line with a little waste and lowest possible cost. And you want it to be on time and defective free. So you need much smaller amounts to develop in continuous processes than for batch production. So that can significantly reduce your costs. Continuous flow manufacturing has many advantages, such as the faster output, your cost savings, your environmental benefits, and flexibility. And it can also give aid to the pharmaceutical production needed for clinical trials. So this will ultimately help speed up new drug breakthroughs. So the pharmaceutical industry's production is wasteful, time-consuming, and expensive, and it ends up leaving a huge footprint on our ecological world. So the lead time right now to make the pharmaceuticals using batch production is as much as 200 days or more, and cost manufacturers as much as $50 billion on wasted efforts annually. Now, continuous flow manufacturing can reduce your lead times to under 2 days, and it costs about 50% less on average, while reducing inventory, improving quality, and being safer for the environment. So, the advantages of continuous flow manufacturing far outweigh those of batch production. We'll see shorter processing times, increased efficiency, more flexible operation, lower capital costs, smaller ecological footprint, and consistent quality. And those are only some of the few advantages over batch production. I believe that continuous flow manufacturing will shape the future of the pharmaceutical world. Thank you.